The companion to that 78 Marshall that just came in is this beautiful 65 Deluxe Reverb in just stunning clean shape. It almost looks like it's maybe a year old at most. It's had a recap and a new power cable. I don't know everything it's had yet. I'm about to look and find out. The owner wants to be sure that it's as good as possible. So let's take a look. I took the screws out so you didn't have to hear the sound of the electric screwdriver, but let's peek under here together for the first time. Nice. F&T 16 microfarads, 475 volts. We'll double check to make sure with the rectifier tube that the B plus cannot exceed 475 with modern wall voltages. And just gotta check real quick, make sure there's no voltage waiting here to get us. Now that all looks good. It's got a little bit of paper here. Someone cleaned the board and a little bit of paper caught on the solder joint. That happens. Very pretty. The leads are nice and curved. It's got some silicone beneath it. Has original 10K dropping resistors. Now, I usually end up replacing these, but they usually don't look like this. These look brand new. So let's see what they measure and see if they're candidates for staying. Oops. Ohms, not voltages, not volts. All right, so 13.3K, a little bit high, 30% high. 10.8K. All right, I'll consult with the owner. This one's over 20% out of spec. It may be fine. He may want just to know that's absolutely 100% reliable. Carbon composites were what Fender used, but they were not a good choice. Today, they're a terrible choice for the application here of being a dropping resistor in the power supply. Back in 1965, this was about the only game in town. So, as always, I make sure that the transformer hardware is tight. That all seems very good. Make sure the bias pot is on there tight. I can see little concentric marks where someone's tightened in the past, so it probably is. Yeah, that's really good. I'm going to go ahead and tighten the input jacks real quick while I have it accessible from this angle, just to make sure if they need tightening. So far, those are just rock solid. I didn't need to do anything. I can see the amp still has a death cap in it, so I'll at least get to do that, but let's flip this over and take a look inside. Actually, I lied. Let's take a look at the front first. Ooh. Ah. Seriously, you just don't see this very often. This is just amazing condition. If these are our production knobs, I'd like to know who's making them with that 8 that looks just like the old ones. This is either one of the cleanest originals I've ever seen, or someone out there is an excellent fraud who should be gainfully employed. But I suspect they're probably original. Let's see, I'm just going to set these where I usually set it for testing. I like to have the tone, treble and bass pots at noon, start with the volumes off, reverb, speed, intensity off, and it's nice to see that the ones are pretty much lined up with a little mark, a little off center here and there, but overall, very good. The inside of the chassis is still shiny. That's beautiful. I can see that they still have the neutral fused, etc., but that's an easy correction, and I'll take out the death cap at the same time, but this was done pretty well. The ground wire over here is longer than the other wires, and it was at least brought to the solder joint over here for the bias wire, but it should have its own dedicated ground here, but it's better than most I've seen. It's got these 2-watt screen grid resistors. Let's see what they actually measure. $469.9, then went to 470, and 470.8. So yeah, those seem okay. They're not as pretty as the ones I use, but they are just fine. And I think the grid stoppers have been replaced in the past. Let's just confirm that they're where they need to be. 1.6. $1.61. So yeah, those are fine. Look how clean everything is inside. All the yellow wires and blue wires are very clean. There's no tarnish even on the jack plugs. These blue Ajax caps look brand new. The resistors look brand new. The board is very, very clean looking, at least. I'll measure it for conductivity in a bit. They've got these IC brand caps for the cathode bypass caps. In these voltages, the IC caps are usually fine. It's the larger, higher voltage stuff that usually fails. They've got a little Panasonic here across the roach to detick it. Got a Panasonic or similar here in the LFO. Not all the solder joints are beautiful. I'll touch those up as necessary. If we don't replace the cathode bypass caps with something prettier, that's just a matter of touching up some solder joints at the cathodes that aren't quite as pretty as they could have been. The only non-original resistors I see in the amp are a few plates. This one here is a metal film. It's for the reverb mixer stage. This one's for the reverb recovery stage. And down here, there's a carbon film on the phase inverter. I'll talk to the owner and see if he would like me to put in some carbon composites, because I have some nice ones, just so it's cosmetically 1965 again. But what you just saw will work just fine. Bias board is very nice and clean. Again, an IC brand cap here. It's not my favorite, but there's nothing wrong with it, most likely. I'll test it, but I don't need to change something just so that I was the one to change it. I'll change it if it needs changing. All the jacks seem original. All the pots seem original. Someone's removed the bright cap. Good move on a Deluxe reverb. All the resistors here are original. Very nice, neat solder joints going to the brass control strip, which is also very clean. This one might benefit from being reflowed. It's not all the way pulled out, but you can see the wire through the solder. The solder is definitely on top of the wire. But this is probably fine. I'm just paranoid about such things. But then again, that is quite literally my job. Now I'm going to do something which may seem strange or dangerous. I'm going to power it on with only a rectifier tube in place. And that will tell me what the maximum B+ unloaded that these filter caps will be subjected to. We've got 122 volts coming out of the wall right now. So that's not a bad stress test. I'd rather know if the caps are going to fail than have it be a surprise to the owner down the road. There's a not so great chassis solder joint here. I'll clean that up, of course. I just saw that over here. But let's take it out of standby. And the maximum unloaded B+ is 484.9, 485. Turn it off. Those are 475 volt caps. Now, if all the tubes were installed, we would not be at 485 volts B+, be closer to 450 max. But what if you power the amp on and your 6V6s die for whatever reason, or you forget? I just don't want those filter caps to blow up. Now, I'm being a little bit paranoid for the sake of the owner and for the sake of making a point in this video that people should be aware of. That 485 volts exceeds the maximum rated working voltage of the capacitor, which is 475, but it will not have any substantial current. And so it's not really a working voltage. This is right on the edge of what is acceptable. If the owner would prefer, I can get 500 volt rated 16 microfarad caps or 500 volt rated 20 microfarad caps, and you won't hear any difference between 16 and 20. Or he can stay with the 475 and just make sure he always has the power tubes in place before he tries to use the amp. And will probably be okay even if one or both of those tubes were to fail, because at that point the amp would be drawing very little current. So, it's almost a theoretical issue, but it's worth pointing out. I'm going to power it back on because I just want to take some voltage measurements on the board. If those filter caps blow up now, that's fine. I'll change them. I can even say it's on my dime if necessary, but I don't think it'll be necessary. So the first place I want to look is over here, because this junction of this 20 nanofarad and this 500 picofarad is physically very close to this B+ node. And this B+ has got 475 volts on it right now. So what's here? Half a volt. So even though this board is cosmetically beautiful, there is some leakage here. That's going to be coming over here, and that half a volt will be present at the input to the reverb mixer stage and be noisy. And over here on on this coupling cap from the normal channel. We got 55 millivolts on that treble cap there, 24 millivolts, 42. Let's see what we have at the phase inverter input. 50, 30, and these are the usual suspects. Let me check this one here on the reverb. That's good. And let me check the tone stack film caps. They're usually fine. Yeah, so it's these ceramic disc caps that are the treble caps, because they're also very close to this B plus node here and this B plus node here. This stage right here, the same corresponding point, often on the reverb cap, sometimes on the 100 nanofarad here because they are physically close to here, which is a B plus node, and then right over here, particularly the mix resistor attached to the normal channel, because it's in close proximity to this eyelet, which under normal operation has about 50 volts. Right now, it doesn't have any because there's no tube in the phase inverter. So that might be an artificially low measurement I'm getting here. But sometimes, worst case scenario, not very often, but sometimes you'll have a leak from this eyelet here. Let me show you this. Not very often, but worst case scenario, there can be a leak from the positive DC here to the negative DC here, which throws the entire bias off. This is at negative 43 right now. If I take it into standby, stays at negative 43. So there's no leakage from here to here. That's good. So I know what to talk to the owner about. Basically everything I've shown in this video. Ask him some questions about whether he'd like some modern resistors changed back to carbon comps in the signal path, whether he'd like some carbon comps changed to better resistors in the power supply, whether he'd like me to change out the cathode bypass caps just for the sake of having the best thing on the market, which is the Vichy versus these ICs, whether he'd like to up the voltage of the filter caps just for a little bit of extra security, even though this 475 will probably be okay in practice, so long as he has operable 6V6s in the amp. There's that ugly solder joint I was talking about. I can fix that. And there's a splice here on the choke wire. So I don't know if it's a replacement choke, though it is from 1965, or whether someone just cut that wire by mistake at some point, or whether, it was just burned or something. But who knows? An amp this clean deserves just the best of the best of the best, and I'm honored to have been called since that person was not actually available. But thanks for watching anyway.